faculty, staffs, and participants. Very good morning to you all. Welcome to the National Symposium on Frontier in Physics Teaching, organized in association with Indian Association of Physics Teachers, IAPT RC13. Viksit Bharat 2047 is the current government's roadmap in making India a completely developed nation. Viksit Bharat Initiative for Student Innovation and Outreach Network aims for nurturing education, skill development, and innovation. The vision of Viksit Bharat include scientific achievements in successful space missions like Chandrayaan, Mangalyaan, indigenous missile development such as Agni, Akash, and recent strides in quantum technology, which contribute to a stronger, self-reliant scientific ecosystem. It establishes advanced research facilities and encourages young talent to pursue career in science. Although there are many advancements in the field, it is very crucial to prepare the students for addressing unseen problems which evolve from time to time. The incorporation of a range of methodology are needed for enhancing effectiveness of physics education applicable to real life problems and beyond. The session mainly highlights the importance of some of these approaches with examples and demonstration. This would create a meaningful impact which will augment creative thinking and analytical abilities and pave way for indigenous solution so as to fasten our progress for Viksit Bharat. Let us seize this opportunity to learn, collaborate, and inspire new ideas. Together, we can shape the future of physics education. Once again, welcome and let's make this a memorable and transformative experience. Now, I would like to call upon Priyanka B to give introduction about Dr. Vandna Luthra ma'am.
Honored guests, esteemed participants, and dear audience, a very warm welcome to all of you. Today, we have the privilege of introducing a highly accomplished person as our chief guest. Please join me in welcoming Dr. Vandna Luthra, Professor of Physics at Gargi College, University of Delhi. Dr. Vandana Luthra's career is marked by significant contributions to the field of physics. She has been awarded prestigious fellowships such as the Boy Scouts Fellowship and the Raman Fellowship and has been a visiting researcher at University College, London, UK. She is an office bearer and active member of IAPT RC1 and Institute of Physics, UK. She has served as a resource person for regional workshops on research-based pedagogical tools in different parts of India and has trained over 300 undergraduate teachers. She has established a physics laboratory at Gargi College and supervised 5 PhD students. Her dedication to education and research has earned her numerous awards, including the Meritorious Teacher Award by NCT, Government of Delhi 2012, and the IAPT Deenabandhu Sahu Memorial Award. Dr. Vandana Luthra has completed several research projects and has published over 38 papers in international journals. She is also deeply involved in science society initiatives and training programs for teachers and students across India. Now, I would like to call our chief guest, Dr. Vandana Luthra, to take over the podium and share valuable insights with us.
Thank you so much. Thank you so much, and I am thankful to the authorities, the college, Dwarka Das Govardhan College, and Dr. Luthra and Professor Natrajan, Dr. Renika, and all the participants for your warming, overwhelming welcome to me.
Ma'am, can we get this?
Yeah. Am I audible? Okay. And this is my first visit to Chennai, and I'm really overwhelmed by the kind of warm welcome given to me. And I think I will cherish its memory over the years. And in this regard, I would be starting my talk on. Can I begin the talk? Yes. So let it begin. Half my job has been done by my previous speaker, Professor Jayakanthan, in that he exemplified the role of multidisciplinarity, why in physics we need to interconnect with other disciplines also, why there is a need for that. And when we are talking about NEP 2020 or we are talking about Viksit Bharat, what are the kind of technologies or methodologies which we need to incorporate into our teaching also, so that it becomes an interactive classroom rather than the students are just the passive listeners. So my talk is titled as Effective Classroom Strategies for Transforming Physics Education, and specifically what all is required for a Viksit Bharat. So in this regard, I need to move it like this. Let me do that. So I will begin with my video of my college. It is, can you just play this video? Uh, access is already there. I have already made you editor for that. Okay, I can just speak like without the video. My college is situated in South Delhi, one of the prominent women colleges, which is A plus by NAC accreditation, and it has got a star status, which is given from DVT to all the science colleges. Not the previous one, this one. Okay, leave it. Then we can move forward in case it is not opening. So it is one of the prominent women college, and we are catering to sciences, humanities, commerce, and education department. Now the college strength of the students has increased to 5,500 in a particular semester, and that is actually is too much, because now with the all kind of expansions, this number is too large for our college. But in this particular case, we try to provide the quality education which is comprehensive, and that these are some of the things which I think are, if are incorporated in the class, that is going to help the classroom strategies. So these words by Confucius are always encouraging, which says that if I hear, I forget. And if I see, I remember. And if I do, then in that case, I understand. This is an example. 15 years, I think 14 years back, Professor Natarajan visited our college. And that time, he had a bag full of all demonstration on the stage. And in that case, our then principal, we all were mesmerized by that particular session. Our then principal also attended. She is otherwise from English background, but that day she sat and she attended the whole lecture. After that, after the lecture, she announced that students should do research. They should do some innovation. So she instituted a prize that was Pathfinder Award. And that Pathfinder Award was for students to carry out a research under a mentor, a teacher, for 6 months. And then they present their results in front of external, say, exhibitors or external guides. And in that case, anyone will win the prize. That particular instant, it was declared. She, I think, formed a means for organizing this kind of award, and for last 15 years in all now sciences, humanities, and commerce, this award is there. And every year students do research. One of my students which I guided long back, that student, now she won it twice in the beginning, and now she's in ISRO. She's working as a scientist. And all, I am sure, all the students who have actually undertaken that, and that was the impact of the hands-on. That was the impact of a session in which you take something from the session. So I would also want that this session should be interactive, and there should be some take-home message. Whensoever you go home, you think about that what all you can do when we are talking about it. And it is not preaching. It is not telling you something. It is just sharing. Whatsoever journey I have traveled, I would like that from that journey, if all of us can collaborate, or they can be networking during this conference. So that is the only motto which we are talking about. So moving further on, overview of the talk is going to be like concerns about the physics education. followed by some examples what are the effective strategies, and those are going to be research based pedagogical tools which I practice, and I have trained many teachers on that across the country. Interfacing of experiments, what do we mean by that, and how to implement that, followed by interdisciplinarity. I will be showing some case studies that why there is a need for interdisciplinarity, followed by embracing to fast changing scenario, whether we like it or whether we don't like it. In that particular case, the changes have to be adopted. It has to be taught to our students in a manner that they are able to understand. And some of these are artificial intelligence. All our students are using chat gpt. They are much more advanced than us in a manner. They are learning very fast, so we also should not be left behind. Same is the case. This is an international year of quantum computing. So quantum computing is also something which has to be told to the students in a manner that they are able to know that what all is happening, and other than that is the summary. So let's make this session interactive. Do we have concerns in our classrooms? So can some of you, one or two people can tell me, participants can tell me, what are the concerns in the existing classrooms? Anyone? Just one or two? I think this is going to be globally same. It is not that it is localized only to Tamil Nadu or to Delhi or to India. These kind of problems everyone is facing. Their form may be different, but problems are always there. So may I request one or two to kindly tell me that what are the concerns in their classroom? You can take the mic and please tell me. Yes, please.
You're asking the question, basically the short attention span of students.
That's right.
Their inability to connect with what we say. Sometimes I think we are from the dinosaur age and they are the newborns, and the synchronization of what we say sometimes doesn't reach them. The main reflection is the short time span.
Perfectly right. Perfectly right. This is one of the concerns which all of us face. Okay. Any one more can be there? Yes, please. Yes, you are perfectly all right, ma'am. That interaction is something which is essential in a class. It happens sometimes we are telling, but they are listening. But what they are listening, they also don't know. So there has to be interaction and a positive interaction. So in this particular manner, I will be starting with the first one, that is the research-based pedagogical tools. I want to go to next one, I think. Yeah. So I will also be telling about my journey, about RBPT. So my first topic is about RBPTs, and I will be also telling about my journey. There were 3 levels of workshops which were held, like these kind of workshops, which were held by ICER Pune in association with Sheffield Hallam University. And in that, the funding was by Newton Bhabha Fund and also MHRD, just for these concerns, which all of you have realized, and we all know that these are the concerns that we should have engaging classrooms. We should have basically interactive classrooms. We should have some more things in the classroom. And after that, they have also conducted regional workshops throughout the country. Especially their motive was for the remotest area where there is lack of, or there is less accessibility of resources or resource persons. So it was held from Jammu and Kashmir to all the parts of the country, widespread, and for training of the teachers of this methodology. Okay, so in this particular regard, if I'm also very influenced by a scientist who is from Tamil Nadu. He is a Nobel laureate, and he is testifying to what Sir said in the morning, that interdisciplinarity or multidisciplinarity is the key for many things also. He is a physicist which shift to biology, and he got a Nobel Prize in chemistry for his work on RNAs and ribosomes. And he says that actually science is simply the systematic accumulation of knowledge based on evidence. Evidence may make it the most important central part when we are talking about science. And in fact, we all are born scientists and we are intensely curious about the world around us, constantly making deductions based on data. So in this particular regard, when we move further, these are the things which are the concerns which are already raised by some of us, that we want that curiosity and creative thinking has to be there in the classroom. Other than that, there has to be engagement, has to be interaction, and are they able to apply the knowledge which they are getting to address open-ended problems? Problems keep on evolving. Same problems are not there. They, with the real life problems, are changing. Like the one in the COVID, we were all unprepared and it happened. Same way, all the problems which we are facing in the coming century or coming days are not the one which was previous. Like sir told about in the morning, mutations are happening. Same form of COVID was changing. So we have to talk about that. If mutation help, then how our knowledge can address to those problems. And the link to a real life problem. We can't teach them that this problem will come and we have to solve that problem. But we can teach a skill set. We can teach a knowledge which is adaptable, which can be applied to other kind of problems which will keep on evolving. And that is what we have to talk about when we are talking or when we are teaching of a particular topic in a class. And that is the real life connect also. All these are ingredient parts which were described in RBPT, which came as a tool. And what does it say? That we do not, our classes should not die down the curiosity of a teacher, rather it should be enhanced. Once a student is curious, passionate, half the job is done. Our classes are going to be more impactful. And in that particular case, this is a penny farthing cycle. Again, this is something which is close to my heart. It was the way cycle was invented in 1800s by penny farthing. One can see the one wheel is larger as compared to the smaller. And thus our teaching is like that the theoretical knowledge is overweighing the hands-on skills. Now we see the form of bicycle. Both the wheels are at least equal. So in a way, we also need to balance out that we are able to have equal wheels of the hands-on practice also as a part which can be to augment the theoretical knowledge. So in this regard, is knowing is equal to learning? And is researching is equal to knowing? How do we learn? What is the procedure we adopt for learning? So in this regard, when we are talking about learning, if there is a research developed concept, then curriculum emphasizing teaching a subject content as developed by research. There may be a topic, we teach that topic, student is learning that topic. In another form, research oriented. Curriculum is emphasizing teaching the process of research in the subject. It is not research per se. It is the research in that particular subject which we are teaching. And when we are talking about research tutored, curriculum emphasizes learning subject content by students writing and discussing papers or essays. And when we come to a stage which is research driven, curricular emphasizes students actively undertaking inquiry-based learning. Inquiry-based learning is something which is making them proactive in the learning process. And if I see the left-hand side and on the right-hand side, on the left-hand side, emphasis is on the content, what they are learning. Whereas in the other side, emphasis is on the processes. What processes they are using in order to learn that content. And the process is the journey, which has to be different than only the content learning. Because if they learn the process, it is adaptable. It can be applied to any other kind of topic and any other kind of things also. So in this regard, again, if I just to see emphasis on the teacher activity if we are on the bottom side, and emphasis on the student activity if we are on the top. So there is a need to go from this left bottom to the right top. so that we are moving from research developed to research driven. Okay, so in this particular regard, what is in the name? You may find if you go to see pedagogy in education and especially physics education, there are many terminologies: inquiry based learning, research based learning, or it can be project based learning, or the learning in the real world. All these are synonyms. Main aim is that the objectives which are our concerns. And in this regard, the workshop will emphasize on how to use or develop RBPT and what does it have, how to develop it for a particular subject with the help of examples also, so that those examples can be utilized for teaching other kind of content also. So in this case, RBPTs are, I go back, RBPTs are pedagogical tools which require research, which recognize research, require research, they refine, reward, and report research. So it is a 5R terminology which is used in it. These are pedagogical tools, not research per se. This is not research, it is research in the teaching or research in the topic which we are doing. And in that, they exist primarily to teach science and mathematics, along with authentic research will occur. When this methodology is used, there is a sea change in the learning of the students. And through RBPT, students develop research experience and skills and acquire relevant domain knowledge also. So in this particular regard, it is important to see that chalk and board system has to be augmented or has to be supplemented by other tools of learning also. So if I ask a question about RBPT, have these been tested? Yes, many countries are using these kind of pedagogies, now including India also, because that project by ICER ran from 2016 to 2019. And in those afterwards were the pilot projects and other regional workshops in which thousands of teachers have been trained across the country on science and mathematics subjects mainly. And is it practiced? So it is practiced worldwide for schools and higher education. At that time it was for undergraduate students, but it can always be adopted and used for school students also. What are the benefits? So benefits I will be discussing in the forthcoming slides. What are the constraints? If we talk about any tool or any technology, any device, we have to see the accessibility. Accessibility of time is something which is most important, that we are all bounded by our curriculum. We are given a set number of experiments. There are the different other kind of constraints within the class when we are talking about. So how to basically overcome that constraint, which is of time, resources, all that also can be discussed. And in that case studies. I will be showing some case studies in which it will show that how a topic can be connected to a real life problem and can be beneficial in the class. So far so good. Everything I have talking is clear to everyone? Yes. Okay. So moving further on, what are the benefits of research when we are talking about? A majority of us may have done a dissertation or a PhD or any other kind of research also. So it starts with a literature survey, where we are now. When we are talking about what is the current status of that problem, what are the methodologies I will apply, I will utilize, and other than that, a team of people. It is never, no person can do research all alone. There always has to be a peer group, seniors or students or something to whom we can supervisor. There is a team of workers there. And they were, as sir told in the morning, those are the places when actually networking happens and collaboration happens. And other than that, a method which we, after reading those papers, after looking at that, what are going to be the basically research gaps in the problem which we are going to talk about, it is always there. We devise, think of a methodology or a particular procedure which we are going to start, and final products are going to be a thesis or a viva, and other than that, a lifelong learning which plays a pivotal role in framing or in deciding our futures also. And without T also it is not possible to do PhD. So in that case, over T many things also happen. So in this case, these are the salient features of a research when incorporated into our teaching of a topic may be beneficial, and that is what I am going to demonstrate. So here, this was the first workshop in which there was level 1 workshop by ICER. In that, they had called 150 teachers from across the country, even from all parts of. They had called people from, and in that, I think at that time they had selected star colleges because those were colleges which were running star college scheme. That was the first workshop. After that, they selected 30 teachers to do second workshop, second training. In that, they taught that when you become a trainer, what all you are going, how you are going to conduct these workshops. So that was sort of a training, the trainer mode. And after that, in the third workshop, it was a writer's workshop. Whatsoever we do and are doing right now, there has to be a documentation for that. Suppose I develop a RBPT. A group of people is working from across the country, and we had trainers from other country also. So there should be some outcome. That is what when we talk about when we are talking and making an objective in a class, that what is the outcome of this lesson. So all those experiences in 5 different streams were documented in the form of a model RBPT, which is available at the ICER Pune website under the COSME. Those who are interested can always explore that how the lesson plans, how actually a particular kind of RBPT can be prepared, and that was for use for everyone. So in the third workshop, actually, there was a documentation of how to write that, how to make it available to the other students, other say teachers in the country, or also the student for that sake. And in there, prior to this, we had trained at many places in India. We could see that what are the research problems which are existing when we are talking about and that was not only for physics, that was for all the sciences and mathematics and statistics and food technology also sometime. That what are the kind of problems, and problems change from place to place also. Sometimes we should also emphasize on our local problems. Whatever is happening in other part of the country may not be relevant locally to our problem. So in that case, there is also a need to see what are the problems which are basically there locally. And that also was, we got to know after training teachers from across the country. And so, as I told, these are all. This was at St. Joseph College in Bengaluru, and same way there were many other which were conducted, and you can see the joy of the participants when these activities were done enthusiastically, because something which is done enthusiastically again has a very far-reaching impacts on your learning, and basically engaging or basically motivating our students for doing these kind of stuff. Okay, so moving further on, so what are the elements and 5 hours of RBPT? Whensoever we are teaching a problem, it has to be real life problem, should be a hook. It should have a context. Real life problem can act as a background and a hook, like why I am studying this particular topic. Does it have any say advantage, or does it have any relevance to a real life problem? If that kind of thing is also basically found out, is isolated, in that case, one students, it is very important that students will always be encouraged to read that. That is why maybe I can solve this kind of a problem when I am doing this. So this kind of a hook is very, very important in basically formulating RBPT. So why do we do that? So delivery is not one way. Students also own a partnership. When they are doing something, they always own a partnership. It is not only that only the student teacher is talking about. A student is always our partner in that particular association. Teacher is a facilitator. So there is a need for a role of a teacher also to become a facilitator for these kind of projects. Other than that, more engaging. It is going to be more interactive. Teamwork is always there. And then sharing and networking, presenting the data and application to the real life problems and problem solving. So problem it takes a central stage. In that particular case, context is playing an important role. And then the skill, whatsoever skills are getting basically developed, those are going to be transferable skills. Those are not problem friendly skills. Those can be transferred to any other say problem also. So what are the students doing in that case? Again, we need to move from identifying to authoring, from the top bottom to the bottom left to the right top. That in one case on the x-axis we are going to have domain knowledge and inquiry sophistication. On the y-axis we are having student autonomy, and there is always a requirement that we move from one quadrant to another on the top. So RBPT should incorporate these 5 R's. So when we are designing RBPT, it should require research. Questions can't be answered from memory. So there is some sort of research is required in that. It should be first thing should be, it should recognize and then it should require research. And when we are talking about require research, there should be any 2 things minimum, like problem solving or methodology, which should also be a part in which students are actually doing things, followed by refinement. Refinement can be of, suppose we always do one kind of a thing, then it has to be improvised. So refinement also has to be done in a manner that it also is incorporated within that procedure. And rewarding research, in that one rubric has to be devised, that how you are, because when students are doing something, there has to be a rubric in order to basically reward that. And reporting, there can be an open seminar, there can be a publication, there can be anything in which students are given a chance to present their work, so that they have a peer review feedback also, and they have confidence building also. And group work, as I have already told, that is also a part of this particular procedure. These are further more defined things on refinement and what do we mean by reporting and rewarding. Because in rewarding, there has to be assessment. It can be formative, it can be summative, it can be periodic or terminal. Any mode which a teacher would like to think pertinent for that kind of a problem can be taken as a basically rewarding process. Other than 5 R's, it should have 6 elements, and those elements are context. What is the context? Because we are all bounded by our curriculum. So the context has to be there. Problem, what are the problem which they are going to solve? And activity, what kind of activities they are doing? And then what are students doing, designed or done by students? So they can be 2 different groups also working, and then there can be a comparative of studies also. This can also happen that one group is doing something, another group is doing another thing, and that comparison can also help us in generation of data in a much better manner. And in that case, resources. Internet is full of plethora of resources. So in this case, it is also important to identify the relevant sources, relevant website, relevant other kind of, say, resources which can be utilized by the students in a very periodic and very systematic manner, rather than they are searching endlessly on the net. And then output can be, as I told, it can be in a form which a teacher can decide that how the output can be generated. So I would be keen to say, I can just leave this because I have to cover 2-3 more things also. How to initiate a RBPT? Again, this is another way of representing only the things which I have already devised. Applications can be, you can choose any topic of your syllabus which you think can be converted into RBPT. After seeing the model RBPTs, it can be any topic which you can think, irrespective of what subject you are talking about. If you can also include interdisciplinarity in that, that could also be possible. And again, important thing is the real life application should be an integral part of that. So I would be giving some examples. I can straight away go to, one can follow these processes in which one can pen down a context, one can pen down problems, one can pen down activity, resources, output and assessment. and timeline for each is also required. That is also something which should be a part of it. So I straight away come to the model RPPTs which can be utilized in physics per se, but these are applicable. One can always see its connection to the other fields also. So same problem can be seen with a different angle by another subject also. So these days it is possible to actually demonstrate or find out the components of interdisciplinarity in different topics, which also I'm going to show in that. This was a particular, when we are connecting to a real life problem and when we are basically finding a context, that context can be a picture, it can be a video, it can be anything, reading material, it can be anything which you think can go as a context. So there was this article in newspaper that light emitting diode as lighting scores, gleam of city versus energy saving, whether it is a queen's necklace which is golden or platinum which looks like good. So in one case these are the sodium lamps which are on the left screen, and on the right hand side these are LED lamps which are there, and it says that by are we going to replace the gleam of the city by replacing by energy efficient bulbs. So aim can be centered around LED. And in LED, when we are talking about, we teach in school level or in undergraduate level IV characteristics of linear and nonlinear devices. That is where we start these kind of subjects. And then in that case, energy efficiency is something which we talk about when we are talking about climate change, global warming, that all the conventional bulbs need replacement. And in that case, so there can be activity centered around these. So what are our objectives going to be? So what is the story? LED are to be replaced by conventional bulbs. It can be a study in our institutes that what is the wattage, what is the type of bulb, what is the life of that particular energy source which is being used in the college or any other institute. And then the one-time replacement cost is quite high, but will that energy saving help us in basically investing in this kind of a project, and how much years it is going to take? And if we are going to say replace these, is there what will be the contribution of the two in terms of global warming, in terms of efficient energy resources? And these days it is also important that we should always see the working of the LED versus the conventional bulb. So we will need to do IV characteristics. So maybe our topic in the syllabus is to study the IV characteristics of the linear and non-linear devices, and to study that what kind of equations they follow. V is equal to IR, or if it is a different kind of a LED, then what kind of equation there it is basically being followed. Followed by, is global warming linked to lighting, or is there a reduction in e-waste when we are replacing from one kind of bulb to another? So all these are societal problems. And when we teach in our class, probably we just start with IV characteristics, but in that particular case, their linkage to the real life problem is also which needs to be appreciated by the students, that where all this is required, because semiconductor industry is again a very huge industry now with a lot of initiatives being done on that. A lot of job opportunities are also there. There are changes in the design of the LEDs also in order to make them diffused or in order to make them different kind of energy resources. So all these are connected things which needs to be done as a comprehensive study. In one or two problems if we cannot do it, as I told that we have to talk about the constraints also. Our semester may not allow us to do all the problems in this mode, but at least in one or two problems per semester we can plan to do these kind of studies. And again, you have to formulate a group of teachers who are teaching that particular topic and are interested to make or develop these kind of a product which is available for other teachers also, because after it is read by other teachers, they also implement in their class. A process of improvisation occurs. Their ideas can also be incorporated, so it can be a ever changing, ever evolving document which is getting updated with the passage of time. And that is why we also need to adopt these kind of things in at least some of the problems when we are doing in our classes. So you have to, what is the role of teacher here? As I told, teacher is a facilitator. Device of all these, that how much time, resources, what are the outcomes is there, should be clear in a teacher's mind. And it has to be given to the student as an activity. So in that particular case, we have to monitor the progress of a student also during the way. It may happen one group is doing one kind of study, another one is doing another, so they have to again see the methodology which they are going to adopt. It may happen that there may be a process may be different and outcomes may also be different. In that case, openness of the thoughts, creativity, these are the kind of outcomes which are there if it is done in a systematic manner. Same way, we also do different kind of, so all this e-waste is also something which is very important to think upon, that where all these, we are saying these many million electronic components are being generated, where these are going. These are having toxic elements, lead, cadmium, and other kind of toxic gases are getting evaluated. And when they are being landfilled, that is going to be connected with our soil, water. So their impact again on the health will be there. So one has to be careful about e-waste generation of these basically components or devices also. We give an experiment to do diffraction of a wire or an open single slit and so many other. That is a set experiment. You go, we ask student, go, this is the setup, do this experiment. So has to be a creativity in asking that what kind of setup can give me this kind of a spectra. What should I do if I want to change my what parameters should I do change in order to bring these changes in my spectra? So there can be a thought-provoking questions which can be added in order to do experiments also, because those will always think again in enhancing creativity, in enhancing the thinking abilities of the student, that what should I do in order to bring these kind of spectra in my class, rather than just doing the set experiment, which in a class of 50 all the students are replicating the same kind of setup with their observations. So do we need to think about these things also? That there has to be something in which there has to be enhancement of their abilities, their observational power, their creativity, their doing things. All this needs to be again has to be given a different thought. So this was about RBPT. As I told that there are many model RBPTs are available. One was on nanotechnology, another one was on sensors. It is available, freely available on the ICER Pune website under COSME. All the details of the different workshops which I talked about are also there. And one can always think of, say, basically going back to those and see which topic in which it can be applied on. And this is how I think there can be generation of resources which can be utilized for the classroom teaching. Okay, so in this particular case, normally we conduct this workshop for 3 days, where after 3 days, a student or a participant is ready with a RBPT which can be taken up to their class directly. That is how I learned. So those kind of workshops are the model workshops in which, from the conventional classroom, how to switch over to other, in which we can incorporate the evolving technologies or evolving changes in our curriculum can be incorporated. Second thing is this one, which is again very close to my heart, because this is a device. I think previous one, the beginning. Yeah. When we are talking about, so this is the second part of my talk, that is interfacing of experiments. Interfacing of experiments would mean that in a lab, when we are talking about electronics experiment or otherwise, students are given a limited amount of time when they go perform the experiment and come back home. Are there low cost devices in which there can be a lab at home, or there can be versatility in which what are the advantages? When we are teaching physics, we are only teaching physics. When we are teaching computer science, we are teaching computer science. We have to see, is there any interface which can be there in teaching of physics aided by computer languages or other hardwares. So this is a device, XPICE, which has been developed by IUAC. IUAC conducts workshops every year, twice, for 6 days each, in which training on these devices is done for classroom teaching again. And there you can, they are all, I think it is all funded procedure by government of, it is by UGC, IUAC runs by UGC. Uh, from each state, normally they select one teacher because a total cohort of teachers is approximately 25 to 30. Every year, twice this happens. All of you can apply. Sometimes they fund to the research fellows also, young teachers also, irrespective of whether you are in school or colleges. So one can always apply for these. So in this case, physics experiments or electronics experiments can be done with the help of this interfacing device. So I am carrying one interfacing device with me, which is called XPICE. I call it as a versatile magic box for me, because in this, there are different pins on which you can make circuits. So I have made my circuit on a very small breadboard, and then you connect it to your laptop, and your laptop becomes a function generator, it becomes a CRO, it becomes a power source also. Other than that, what advantage I feel is most important is this, that in this the coding is being done in Python. So you are using Python for doing physics experiments. So that is something in which you are learning a computer science, basically programming language for the application of physics. So that has, I think, has manifold advantages. This box has got basically applicability in 3 different forms. If you are a novice or you are a beginner, then in that case you can just, there are some programs which are already written and instructions are given that how to make a circuit on this. So you can run that, and in that you get the results. If you are in the intermediate level, you have learned how to basically work on standalone experiments, then you can devise your own experiments. That is the intermediate level. And advanced level would mean that you have got a full knowledge of now Python. You are clear that what experiment you are going to do, perform, and in that case, what is the hardware required also for that? Because you will actually, it is not simulation. It is actually doing an experiment with in which the instructions are coming from Python coding. You are making that particular thing to happen with the codes, and in that case, then that becomes a advanced level. So there is a scope for a lot of creativity. IUAC has in this particular regard has, I think, trained more than thousands teachers across the country, and they have become now ambassador. Some universities have adopted this as a certificate course. Some are incorporating this in their curriculum and workshops and for projects. This is something which is different than the standalone experiments. You can think that it is like Arduino, but in this case, there is a website on which you can get to know that how to code in Python also. A lot of support is there. Dr. Ajit was the one who had developed this, and now he's superannuated, but this project is running very, very nicely. I go there as a resource person twice a year for last many years, and I see again there are teachers from across the country, so we have a chance to interact and see what are the things which can be done. So I will be moving forward with a demonstration. So this is the kit. This is the advanced version. Prior version was called XPICE Junior. This is called XPICE 17. And in that, it has the capabilities of performing electronics, mechanics, sound, thermal physics, electrical circuits, and there is an addition of I2C. Basically, sensors can also be added to this. So all sorts of distance sensor, all pressure sensor, humidity, temperature, all are also now integrated with this. So one can directly plug in, if the sensor is I2C, one can directly plug in and start working, and data acquisition is happening along with it. Okay, so I will be happy to, so when you connect it to your CRO, I have got it with me. Anyone who would like to see its demonstration live also, I will be happy to demonstrate to you, and you can then think that how all this is basically happening, and this can be useful. So in this case, when you connect it to a laptop, you get a 4-channel CRO in which you can measure your voltages, you can measure DC voltages, frequency, all the function which our CRO does is available along with the 4 channels. That is something which is very useful sometimes, because when we are doing an comparison of data, in that case it is useful. And uh, number is, I think, in thousands now, and I think this number I have written mine, that I have trained these many, but IUC has trained many teachers. So this was the previous version. They have also evolved over the years. First version was Phoenix, second was XPICE Junior, third one was XPICE 17, and now there are other modifications also. So one can see that in this there are different you can say pins available for functioning, and you have to just connect. There is a cable through which you just connect it to your laptop. That is the only thing, or there is no external power supply is required. Everything is inbuilt in that. So in that case, it has got voltage, DC voltages for applying to a particular, say, circuit. So I demonstrate here the example of a IV characteristics of a diode. In that, we need a power supply, we need a current emitter to measure the current, and other than that, we also need to measure the voltage which is coming out of the voltage source. So all this is available here. So there is a video which I can play. So these are the different say points on which there are ground, IN1. These names have changed in the newer versions. They are now replaced by PVS and A1, A2. PVS is a automatically DC source in which we can change the voltage as per our requirement. So this is the circuit of the diode characteristics which is being explained here, that you have got you can take a Zener. This circuit works for a Zener or a LED or a normal diode or a silicon diode, and then you connect this through a cable to this laptop, okay, and then you run the code. So this is your laptop screen now, on which it is acting as a CRO or as a data logger in this particular case. And then when you click on this, so this is a standalone experiment which is already documented there. So when you click on the start button and go to that particular, this is a list of experiment which is already there. But if you want to develop your own experiments, then you need to understand the coding so that you can then utilize it according to your requirement. But if you just are learning as a beginner, then it can be just a already built-in library can be utilized. And now a new version has come which is now interfaceable with the mobile Android mobile also, and it is available in the Play Store for incorporation as a app. So have I missed that? Huh? No, did you see the IV characteristics? Okay. So this is the circuit through which it can work. I can move forward. This is what you must have seen, that it generates on its own, and then one can analyze, because the Planck's constant, Boltzmann constant, all can be calculated by studying the diode equation and doing it for different LEDs. So that is an extension which can be done out of these experiments. So this was just one experiment through which there can be a different sorts of experiments which can be done. Interdisciplinarity is my third topic. Do I have time? 5 to 10 minutes more? Okay, interdisciplinarity is something which is the need of the hour. This is an example of air pollution. So this shows that it is a topic which is a part of physics, electronics. When we are talking about measuring air pollution, devising gadgets, electronics is there. When we are talking about the aerosol functioning, all chemistry, atmospheric chemistry is embedded in that. When we are talking about clean cities, when we are talking about circular economy, all commerce, policy making, all these are embedded in that. Climate physics is something which is very much affected with the air pollution. So when we are talking again, suppose I have taken the physics part of it, then it has to be emphasized its importance in other branches, and in those it is, I think it covers majority of the branches which I have prepared here. And if anyone is interested that which part they are interested in, I would be happy to share. And same way these charts can be made or developed for other topics also. Sir in the morning talk about biophysics, and he talked about so many other methodologies. So these interdisciplinarity, multi-trans, these are also which needs to be incorporated when we are talking about these subjects. So active learning approaches is something which is required in the classroom for enhancing basically interactions and engagement, and along with central to our topic which we are talking about, because that is the main thing that plays as a pivotal in when we are talking about these. So suggestions would be that, as I told, that any one topic can be chosen in one semester. The model ones can be seen for just seeing that how to develop RBPTs, and that can also be a then those can be over the years that can be improvised, and those can be incorporated by taking suggestions, or it can be given to others for improvisations as well as feedback, and that is something which can make it better and better. Next is fourth thing is embracing next thing is embracing the latest happenings. So when we are talking about AI, machine learning, or quantum computing, these have penetrated different fields. In physics also, when we are talking about data analysis and machine learning as well as deep learning are something. Patterns in data is something which is required in material science or any kind of study which we are doing. The physics cannot be isolated from that. If I say this is my pattern, it can tell me that I am also, if the pattern is the same. Otherwise, it will say that it is not having that particular pattern. So in all the fields which we are talking about, whether it is particle physics, whether it is material science, these patterns are being unplugged, and in that case students of physics also need to have this knowledge. So there the role of collaborations is to be there, because when they are studying the core subject, in that they also need to learn all these languages which are mandatory for learning machine learning or deep learning. And Python is in these cases remains a versatile language which can be tweaked to these kind of applications also. So it can be done using Python, MATLAB. In MATLAB, there are built-in programs which can be utilized, and the data is available in Kaggle. And from there, one can start learning, and one can see videos that how these things can be incorporated. And handshake with the computer science faculty in this case will be the most useful. And scikit-learn, TensorFlow, and Keras are some of the things which are also required for machine learning when we are talking in physics or otherwise. And this is a very good resource which has come in 2019 for the beginners. If they want to study, they can always start from here, and they can see the methodology. Once they understand the methodology, that can be applied to any problem, whether it is that of physics or chemistry or anything. So it is being utilized for, there are some missions or satellite data we are getting in which there is a data 1 million, 1 lakh data points. So there it is not humanly possible to basically classify whether it is a star or whether it is a different kind of a celestial body. So there in those cases, when the data is huge, patterns in data helps in telling in the classification, which is one of the model which is used in machine learning. Same way, when I talk about the other topic, which is going to be the quantum computing. This year is the International Year of Quantum Computing, and in that, by UNESCO, in that case, how to prepare our students for ever-changing scenes like quantum computing, in which there is a struggle to make a efficient quantum computer which is having less errors, in which there is which kind of qubits are going to be the most successful ones. Everyone worldwide, Google, IBM, there are so many other countries which are apply. Are our physics students ready for that? What else they need? They need mathematics as a core ground. They need linear algebra. They need matrices to handle when we are talking about gates, because gates can be realized in terms of these matrix elements. They need a knowledge of material science. They also need quantum materials, as is also getting developed theoretically as well as through experimentally. Same way nanotechnology. And when we are talking about this, these are made up of superconducting. When we are talking about qubits or superconducting materials, they are to be basically run at low temperature. Role of cryogenics is also there. Electronics, because all these devices with the help of nanotechnology are being are being housed on a chip. So nanotechnology also plays role in conjunction with electronics and engineering and theoretical experimental simulation. All these are different branches and through which one can gain these knowledge. So one has to understand that, and quantum physics will remain at the central, because and all these probability statistics is also an integral part of it. So we can always learn ourselves from the very basic level, that where my physics knowledge can be employed in these advanced fields like quantum computing. IBM has got given access to so many countries, including India, in which you can work on IBM computer. We can make quantum circuits, quantum gates on Qiskit, and one can do programming in Python, and one can see that how these gates are working, which are called quantum gates, in analogy with the classical gates. What kind of changes, paradigm shifts are there when we are talking about qubits in analogy to classical bits? So in that case, what are the superposition, entanglement, and going to be the teleportation rules which are physically explained to a student which is a physics student? And take my words, physics is a training, and that must be true for all the science subjects, which trains you for adopting any fields later on also. So whatsoever knowledge of the core subject we are doing may be influential in other field understanding also. So it is not that we are left behind. We are, whensoever we have a chance, we can always go into or delve into these kind of subjects, and those are, I think, we need to motivate our students also in this respect, that these are not, we can always think of small areas in that, in which our knowledge with some evolution can be adopted and can be utilized. So way forward would be to, I go to my backslide, embracing latest technologies, not with a fear, but with enthusiasm. That is something which we need to do. And finally, comprehensive knowledge is most important rather than just standalone or individual, because if we know the comprehensive, we are given the comprehensive knowledge, then in that case that has much more far reaching relevance to real life problems than the ones which we are talking about in the standalone. A new journey has to begin with the hope that it will continue, but this can only happen when we ourselves are convinced that this is something which I need to adopt. It can be any device, any technology. We may be very attracted to something when we see it once, but a pursuance and there is a persistence which is required in order to go through, because otherwise there will be too many things with no clear cut outcome. So in that case, perseverance and continuation is also required. But first thing is that we ourselves should be convinced that I am going to do this. I will find out people who are interested to do this. I will make a team and I will contribute in that team as a responsible member for the betterment of physics education as well as the growth of the country, which is my next slide. So my acknowledgements would be to my principals. All my principals have been very supportive. Ours is an undergraduate college. We have now our facilities for PhD students over the years by doing many projects by different funding agencies, and our principals have been very, very encouraging in this endeavor, as well as funding agencies. I had a chance to get funding from DST, UGC UKD, Delhi University Innovation Grant, and NASI India. In all these grants, I wholeheartedly acknowledge their support, because it is because of them I have been able to understand and utilize these kind of processes, and especially the students, because students are always the motivators for us also. Thought provocation comes from the students also. So that is what I feel, and all my family and friends. I'm thankful to the efforts in the knowledge partners, in this case ICER Pune, DBT, MHRD, because RBBT project was by ICER Pune in association with Newton Bhabha Fund, MHRD, and there was a Sheffield Hallam uh, collaborators in that who were our mentors, and I acknowledge all the resources which we are using were basically improvised, tweaked according to Indian conditions, and I acknowledge to them. Other than that, for the training and the contents of the presentation, this RPPT trainers from Sheffield Hallam University, as I said, and I'm thankful to directors IUAC, because they have also been a sustainable project of XPIES over the years. I have seen it grown, bounce and leaps over the years, and all the IUC directors also are instrumental. And Dr. Ajit, who had been the developer for this particular project, and now it is being continued by Dr. VV Satyanarayana. He conducts these meetings every year twice. One meeting is in May, another one is in September, October. So anyone who is willing to learn this can always avail of this opportunity. And then all my mentors, Professor Shashidhara, Professor Natarajan, many have been in this journey, whom I cannot name. Professor Ajoy Ghatak. Day before I was talking to him, he's 85 now, and he says, for all my projects, still, all my talks, I also keep on learning, and he works so hard. He's so inspiring in this regard. Professor Anurag Sharma, he is chairman of Delhi chapter of NASI. I see the amazing, kind of energy or recharging after talking to these mentors, and I am thankful to all of them from my whole heart, and this is what I can say. So I would say I want to satiate my never-ending desire to learn, which is relevant for today and tomorrow as well. Because whatsoever is relevant today may change. So anything which we are learning should be relevant for tomorrow, and especially the skill set or the methodologies. And in this case, better teaching learning processes play a pivotal role in the growth of our society, economy, and it is linked to our Viksit Bharat ahead. That is what I feel, and I am sure all of us would agree into that. In that mentor list, I would also mention the name of Professor P.K. Ahluwalia ji, who is the president, and Dr. Rekha, who are currently the president and the secretary of IAPT. The kind of, I think, work they are doing in order to spread physics education in a most, meaningful manner is actually very commendable, and I acknowledge that also. So, thank you very much for any questions. And these images are by Upsplash. Thank you so much. Thank you to all of you for your any questions. If are, please ask.
This kit also is available commercially.
Yeah, this kit is available on Amazon for 4,500 or so.
Ma'am, you pointed out to it was a wonderful talk because
Thank you.
many perspectives, many directions, and the participants here are also from variety of stations. Some are from schools, some are from colleges.
That's right. Thank
And
you.
therefore, if we want to take one specific case, let's say in the schools, how or in the college, how do you put this to practice? How do you suggest this be put to practice? You say that bring in some project-based uh, learning parallelly with the parallelly with the syllabus, so that we keep encouraging the students to incubate their ideas and then follow it through the syllabus. Because having project-based learning is a very time-consuming thing within the classroom. We cannot do it. So these RPP is something that runs parallelly with the curriculum, because many times if we need to incorporate in schools, we have a problem that it is not part of the evaluation. Therefore, the schools may not permit that much time. In colleges, again, it needs to go through the board of studies where it really rigorously needs to bring in. So, if we need to do it, you suggest it as a kind of a hobby, kind of a parallel track, or evaluation based, rigorous curriculum intervened framework. So it's not very clear from the resolution amongst on this. So that's the question.
Okay. Thank you so much and pointing it out. As I said, we will also talk about the constraints. So, with the regular teaching, if you are finding it difficult, autonomous colleges have an option of basically incorporating it in any form. That is first thing I would like to say. Second thing is that in experiments we have a provision, because experiment would always mean that we are answering or we are doing a particular experiment. The method or the methodology can be any which can be adopted. As I told, in some say cases, they are offering it as a certificate course also, as a diploma course also. So if there is a willingness, I think ways will always delve into, and there can be many ways in which it can be done.
Listen, the reason for, sorry to repeat this, many universities have this freedom, and some of the major private universities have incorporated something called PB, project-based learning, and they have somehow given a credit for doing this. Maybe schools are a bit hard to do this. Do you see that way? Or?
For school also, I think, as I told, this project was primarily for undergraduates in the beginning. So it will depend upon the teacher. In case sometimes it may happen, some are already available. So those can be incorporated in one form or the other form, in which we are also judging that how a student is actually working as compared to a conventional way of working. So if you can devise a rubric in which you can evaluate these kind of a thing, and for the brevity, that is why I'm saying collaboration is needed to develop the model RBPTs which can be incorporated in the first say phase to a particular class group of cohort of teachers, and then it can be further improvised and things.
And well put that if curiosity can be passed on, half our work is done.
That's right. That's right. That's right. Thank you very much for your question. Do we have any more questions? Please, you can ask. And if anyone wants to see the demonstration of this, is free to ask, come, and I will be happy to do that, because I am carrying it and I have my laptop with me, so I can demonstrate also. Sometime anyone who is curious and want to take it up further can do that also, because I will call it as a lab at home, a magic box, because it also is an answer for your creativity and critical thinking. Okay. So I again thank everyone, and especially the students. Thank you so much, and I hope that you will always be thinking about that how constructively, how positively we can contribute to the physics education in a manner that it is linked to the real life. Thank you so much. Thanks a lot.